Happy Spirit Week! I'm sure I'm dressed up at the live classes and I'm recording my outfit tomorrow. Now, let's get started on Module 2, Lesson 6. Now, we're going to build and break apart a kilogram using 100, 10, and 1 gram units. I'll show you a time on the clock. Remember to pause the video, give yourself some time. In order to really learn this material, you have to write it down. So make sure you pause and wait. Write the time on your board. What time is it? It is 7:13. The minute hand is between the 2 and the 3. That means 10 minutes plus 3 minutes have passed. The hour hand is pretty close on the 7, soon it will be on the 8. Write the time on your board. Now, click the video when you are ready to reveal the answer. It is 6:47. This one's a little trickier. The minute hand is in between the 9 and 10. So I would count to 45 minutes plus 2 minutes because we have to count by 5s and 1s when it's not directly on the 5. The hour hand looks like it's on the 7, but it's not quite on the 7. It will be 7 o'clock when the minute hand hits 12. Now today we're going to watch some videos regarding an experiment for weight. You're going to watch a person experiment with rice. And as they do so, we will work on answering our problem set questions together. Now, let's get started.
Oh, hello there. I'm just trying to weigh out some rice for a dinner party I'm hosting later. Yes, I have friends. This bag of rice weighs 1 kilogram. A kilogram is a unit used to measure weight. We can abbreviate it by writing kg. But for dinner, I need 2 kilograms of rice. So I'm filling another bag. To make sure these 2 bags have the same amount, I'm weighing them on this balance. You know how a balance works, right? Well, it's a little bit like an equal sign. When these 2 sides have the same amount, they will be balanced. So if I put 1 kilogram weight on this side and a 1 kilogram bag of rice on this side, they are balanced because they're equal. But look, if I put a 1 kilogram weight on this side and nothing on this side, it's unbalanced. It's not equal. So now that I've got my second bag filled, it's time to weigh them. I have my 1 kilogram bag on this side. Now I'll take my second bag of rice. Be sure that your bag is sealed because if it isn't, oh my.
Let's think back to the video. How did we know that her scale was going to be balanced? Because both sides are the same and both pans would have the same amount in them. That makes them the same and balanced. If they have the same amount of weight, like 1 kilogram on each, they are equal, which would balance the scale. Let's keep watching to experiment further. Today we're going to do our problem set together in class. After reviewing the video, let's illustrate and describe the process of making a 1 kilogram weight. Now, I'm going to demonstrate by putting one side on my scale of 1 kilogram, and the other side will also have 1 kilogram. To add on to the question, we're going to talk about what makes this an equal pan balance. I could think the weight on both sides of the scale is equal. That means that it is the same on both sides, so the scale is balanced. You can use that in your own words too.
Going to do us much good anymore. But I do have these smaller bags. But how many of these would it take to equal our 1 kilogram bag? Let's take a look at decomposing our 1 kilogram bag. I'm going to draw a 10 frame on our bag. Now, how many equal pieces have we decomposed our 1 kilogram bag into? We have 10 equal pieces here. These smaller pieces can be measured with a unit of weight that is smaller than a kilogram. We call it a gram. Each of these has 100 grams. We can abbreviate grams with the letter G. So we'll write 100 grams on each part of the 10 frame. Now, how many 100 grams are there in 1 kilogram?
Let's pause and look at our next question. Illustrate and describe the process of decomposing 1 kilogram into groups of 100 grams. Let's first label this with 1 kilogram. And then, like we saw in the video, we're going to make 2 groups of 5 of our 100 grams to make 10 hundredths. I'm using a copy and paste tool to make this go a little faster for me. You can do the same thing by hitting Control C and then Control V. Or you can drag and drop it. Now we see that we have 10 groups of 100 grams. So when we decomposed 1 kilogram into 100 grams, we broke the kilogram into 10 groups of 100 grams. Let's find out why we do that.
Hundredths. Let's skip count to find the total. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So how many grams are there in the bag? That's 1,000 grams. 1 kilogram is the same as 1,000 grams. That's great. Now I know I can use these smaller 100-gram bags. How many 100-gram bags should I fill to equal 1 kilogram? I filled all of these without spilling. Here we have 10 100-gram bags. And look at that, they are balanced and no mess. Now it's your back. Not again. I've got quite a mess on my hands. But while I'm cleaning up, why don't you take a look at this? We can also decompose our 100-gram bags into smaller pieces as well. If we draw a 10 frame on this bag, what will each of these pieces represent? When we decompose our 100-gram bag into 10 pieces, we get 10 pieces of 10 grams. And come to think of it, if we decompose a bag of 10 grams into 10 pieces, we'd end up with 10 bags of 1 gram. Great work today. I don't suppose you want to stay and help me clean up, huh? Yeah, I didn't think so.
Let's think together through the next couple slides on our problem set. This one asks us to illustrate and describe the process of decomposing 100 grams into 10 grams. We saw that in the video. I'm going to take some of my work from the previous slide, and I'm going to reconstruct my 10 groups of 100 grams. Remember, 100 grams is the same as 1,000 grams, which is the same as 1 kilogram. Now we have 1 kilogram. But now I want to see how I can break 100 grams into groups of 10. I know that there are 10 groups of 10 in 100. So I'm going to carefully put 10 groups of 10 over my 100 to show that there are 10 groups of 10 grams in it. It's easier to use the arrows than to try to grab it using buttons. There we go. Now we see that 10 grams fit into 10 groups. And that would be 100 grams, which is only one part of the kilogram. So we decomposed 100 grams into groups of 10 grams by breaking up 100 grams into 10 groups of 10 grams. Let's look at our next problem. Illustrate and describe decomposing 10 groups into 1 gram. Well, I'm going to go back and quickly select all of what I did and copy and paste it to the next slide so I don't have to do it again. Then I'm going to grab this 1. I can see it's very, very small. And then I will start placing that 1 over the 10 grams until I have covered it. How many grams do you think that will take? If it's not perfect, if you're finding that you can't quite get them all in there, that's okay. Let's use another math sense. How many ones are in a 10? There's 10 ones. So when decomposing 10 grams into groups of 1 gram, we would have to use 10 grams or 10 1 grams to make 10 grams. Now, you can move forward to do the remaining problem set problem on your own. What connection does kilograms and grams have with our place values? We know that 1 kilogram is worth 1,000, 100 grams is worth 100 grams, 10 grams is worth 10 grams, 1 gram is worth 1 gram. How does that connect with the other place value chart? What connections do you? Now that we've gotten our practice in, head on over to Edulastic and respond to your exit ticket. Have a great day and enjoy your night. Talk to you another time. Bye.